Find the volume obtained by rotating the region enclosed by this curve and the x-axis around the line x equals 0. It is always helpful if we can sketch a picture, and in this case we're dealing with a parabola and the x-axis, so we definitely can. The x-axis has equation y equals 0. So to find the intersections between the x-axis and this parabola, we're just going to have to solve minus x squared plus 4x minus 3 equals 0. Let's just change the signs. And then we see that we can factor here as x plus x minus 1 times x minus 3. So there's two intersection points, x equals 1 and x equals 3. So how does this parabola look? So let's say this is 1 and let's say this is 3. Then it's concave down because the coefficient here is negative. So it must look like this. And this is the region enclosed by the parabola and the x-axis, so that's the region that we're rotating. And we're rotating around x equals 0, which is the y-axis. So this rotates like so. Now let's see if we should draw a vertical segment or a horizontal segment. This is y equals minus x squared plus 4x minus 3. Notice that if I draw a horizontal segment, then I'm going from the parabola to the parabola. I mean, which we could do, but we would require to solve this for x in terms of y. And we would need to use a quadratic formula, getting some very nasty expressions involving square roots and stuff. So that's not suitable. While if we draw a vertical segment like this, then this uniformly throughout this range has an upper bound of being given by the parabola and a lower bound given by the x-axis. So this would be a good segment. Now let's see what happens to this segment when we rotate around the vertical axis. Well, like this, it produces a cylindrical shell. Use your imagination. And therefore, this is going to be done by cylindrical shells. So in order to recover the region, we need to move this segment from here to here. So we are integrating with respect to x. I'm moving along the x-axis, and the bounds are going to be from 1 to 3. Then I know that I need to integrate the surface area of this cylindrical shell, which is given by, so if this has a radius of r and a height of h, that's going to be 2 pi r, because that's the circumference times the height. So 2 pi r h. 2 pi is just a constant, so it can stay there. We just need to figure out what r and h are. Now in this picture, right, this is x. So x represents this length of the point where I'm considering the segment F. This is the height, so it's given by the top function, which is the parabola, minus the bottom one, which is y equals 0. So the height is simply given by this expression. And now what about the radius? Well, the radius is measured from the axis of rotation, so from here. And it's going up to here. That's the radius of my shell. And I'm saying that this is x because that's where I'm looking at. So the radius is just x. And now I can just fill out this formula in the integral. it will be 2 pi x times that. And solving this integral would give the volume, but I will just leave it like that.